Welcome. Welcome to another session of Power BI Desktop. Today we are going to learn about data analysis expressions in Power BI. You must have seen me writing lots of formulas in the Power BI language, which is DAX language. And this language has helped us make some formulas into the system, make some modifications in the views, etc. So formally, let's deep dive into data analysis expressions and learn and see why and how it is important. Formally, it is a library of functions and operators that can be combined with formulas to build formulas, expressions in Power BI desktop in specific. Along with this, once you know DAX, you can also use the same query expressions or the formula forming method or the syntax to query Azure Analysis Services, SQL Server Analysis Services, Power Pivot in Excel in general. So why do we need data analysis expressions? This was a question asked to me by one of the student. DAX is needed where a designer wants to have his own formula. They want to have its own measures based on the internal working of the organization. It's not so easy. Like if you want to make your own plus operator to mean something else to you, you would have to write a DAX expression. If it is a formula which is not covering a mathematical expression, for example, what if I want to know what was my sale in the month of January for the values or the object socks, for example? In this case, you would either would have to filter a lot of the items to get to that value, or you can directly build a formula into your Power BI desktop which would give you a value by default in one place. So it saves lots of user clicks to reach the same information. So these are the formulas which end your designer or the owner of this Power BI desktop dashboard would make to make life simpler for him as well as others. For example, if there is a constant query of what is my daily, weekly, monthly, or fortnightly sale, in this case, your user would either have to select those date ranges and get to know whatever it is, but a better way of doing things is write down those measures using the DAX expression, and then you can just put all those formulas into one of the KPI cards as one of the visualization items in your Power BI desktop. On those lines, let's have a look at what are the syntax of the data analysis expressions. In general, you would always see a DAX formula always starts with an equal to sign. That sign means whatever you get from the right hand side of the equal to sign would be shown as an output to the measure or the card, or in layman's terms it is a formula, and it would most likely have plus minus asterisk forward slash less than equal to greater than equal to double ampersand operators to the right of the equal to sign, and it will use the tables and the columns as its input to the function most likely, or else it would query the self DAX functions given provided out of the box by the Microsoft. It would either return a scalar value or a table value. When I say scalar value, that means it would be a unique singular value, right? And a tabular value would have number of rows or columns or both. So you can imagine the DAX query beginning with n equal to, having some plus minus multiplication, division, double ampersand operations towards the right of it. After performing those specific operations, what would be returned back as an evaluation of those expression would be either a unique singular value. It can be a word or a number or a percentage or whatever, that would be a countable singular finite value, or it would be a table value. if you have background of programming, you would always have a function and that would return singular value or a table value. It's the same concept carried over in this DAX query. Overall, whatever you write with the equal to sign, right, is known as an expression. So an expression can contain all or any of these operators, constants, or references to the column. So when we say references to the column, that means if we want to duplicate a column or if you want to equate a column to the value of another column, at that time it is a reference to the column. So far so good. Let's see an example. Data analysis expression. See, in this example, we see there's a calculation of total sales being done in which an inbuilt function sum is being called and a sales table's sales amount value is being summed. So if we break the parts of these expressions into these alphabets and if we go through all of them, what it means is A is the measure name of total sales. So you are naming something. The expression has a name, that is total sales. Equal to sign indicates the beginning of the formula. When calculated, it will return the result and assign to total sales. The DAX function column sum adds up all the numbers found in the sales amount column, right? So in this you will learn more about functions later on. Parenthesis is given to surround an expression containing one or more argument. So some function takes one argument. So in programming world, all functions would have a parenthesis, and if there are arguments to be passed, those would be contained in that parenthesis. So that's why parentheses are important. Sum is highlighted in blue if you look over here is because it is an inbuilt function given by Microsoft and Power BI. The reference table is the sales table. So from the Power BI relationships and the tables, whatever you've imported, it's the sales table what we are referring it to. And wherein the column name within that sales table is a sales amount. So with this argument, sum function knows on which column to aggregate the sum. Let's go back and try to replicate this in a Power BI desktop. So in this, if we have a look at here, we have the orders table. And if I drill down a further, I see there is no monetary value assigned, so we can leave it aside. Invoices will have some value of price, right? That's a unit price. Okay. Customers, customer employees, and the products, right? In this, if we have to take the sum of all the orders which are placed, right? So we will have to first see how are we arriving at a value. Is it a revenue? Is it the ticket item? So this is how you should go about going using the function. My ask in this scenario is I want to create the sum or what would be the total sum of my all the invoices. So I want basically a revenue figure as on date for all the sales what we've done till now, and it has to come from this table as invoices will have all these tables. Let's check the invoice table and its fields. So if I go over here and I see invoices table, I see there is a unit price and then I have quantity. So if I multiply quantity with the unit price, it should give me the revenue from that value. So let's go into the table. Okay. And let's open the invoices table. I write a new column which would be total revenue till date. In this, I am saying unit price, so it by default picks up the column from the same table itself. Invoice table multiplied by quantity. So this is what it should give me. If all is the numeric value, then I will get a value next to it. So this is the value of the dollar amount I'm receiving from every product, its unit quantity, right? So if you look at it, the extended price is same as what we calculated. So if I go back and see, it is extended price coming from the default value. This is a calculated value what we've got, right? So I am looking at the revenue which is bought into the system. So if you evaluate this, this is in our example, previous example, it is the measure name, right? So whatever is being done to the right of the equal to would get assigned to this measure. In this case, it's not a measure, it's a column, right? So you have to take care that DAX expressions will have equal to sign, and it would get assigned to either a measure or a new column. In this case, it's a new column, and the way to decipher this, whether to add a new column or a new value measure, is a question what you would ask yourself, which is, will this formula get applied on every row individually or an aggregated row? So would you multiply something in the horizontal fashion and would be applicable to every row? Then you are most likely to go ahead with the additional column. But what if I am trying to check the sum of a value, a unique value coming out of a column, or few values from particular column? In this scenario, it cannot be a column, rather it would become a measure. I hope it goes down well and it's clear when to use a measure and when to use a new column. I have added a new column so that I get a unique value of the price and the quantity. So this is my unique value for every row. Had it been only one unique value throughout the table, that would have been a measure. So now, after having a column with what value I need, I can just rename this revenue from invoices, right? And I can save it as revenue from invoices, right? And I can say okay, so it gets renamed, right? Now I right click on it, I can write a new measure. Yeah, it will show me total revenue. Let me give it a title, right? In this case, let's do one thing. This is the total revenue. Now I can call a function like our example, revenue from invoices. This function what would it do is sum up all the values. It doesn't appear as a new column, but it gets shown like revenue, total revenue, like here. Just see, it is some kind of a measure, therefore it shows some calculator symbol in front of you. This is the small indicator how it works. Now you can happily use this value in your chart. So let me call in, no, I don't want this chart. Let's change it to a normal chart, and I can add a field that is total. Where is my total? Yeah, from the invoice table, I am adding this field total sales. So as of now, I have 1.35 million sales. Now, if I want to filter some data on top of this, I can add filters at the page level, report level, or I can have these values, slicer values at the top of the screen to help filter the value. So let me show you that as well. Slicer value, let me add a slicer. To that slicer, let me add one field. Okay. Let me add a new field, and that field should be based on product type. So to filter it and show it over here, let's take advantage of my orders. Orders is coming from order details. It has shipper. Where are my products? Where are my products? And if I say product name, do I have anything as categories or anything? If that works, no. So rather what I can do is I can use country or cities as one of the filter, right? So if I want to add a filter as city, so from my orders table, I can say ship city. There you are. I'll just take this off. I will take this off. Okay. I can. So this has to change. It isn't changing. That means we have to check the connection. If it is backward integratable, then probably it will go. So if everything is fine, it will allow me to do a backward integration. In this case, when I change over something over here, it allows me to update something over here and here as well. And if I change from the products, but I have changed it rather, let me bring it to the single. Rather, we are working on invoices and the product ship city, right? So the ship city is over here and the sum is also over here. So in this scenario, it has to flow the data from this to this, both ways. Yeah. Now if I go back and I change the value, it should show. There we are. So now I can have these slicers develop for every placard of the information. This can be a very meaningful information. Otherwise, you would have been struggling to get info from the columns as I showed over here, like these two columns. So such formulas based on these spontaneous scenarios help us get all the information in one place with the limited space on our dashboards. So this is why DAX is important. This is how the DAX is used. And now we would move ahead and try and understand what are the different kinds of operator available to us in DAX and what does every operator mean. That would form the base of your DAX learning. And then we slowly move to the next important topic on the DAX as I'll show you as and when we proceed. Let's move on. Next, what we'd see is operators. So, like our earlier example, we did see why did we use parenthesis. It is used to order and grouping of arguments for a function. That is one. And the second is precedence order. That means if you have certain calculation to be done before the other calculations to take place, system understands by the means of considering the parenthesis value to equate to a scalar or a tabular value first, and then use that value for further outer calculations. So it always is inside the parenthesis and then the moving on to outside. Second is basic arithmetic operators, like is plus is for addition, minus is for subtraction, then asterisk is for multiplication, slash is for division, raised to exponential operator is for exponentiation for mathematical purposes. Also, we do have comparison operators like any of our Excel or programming system, wherein single equal to equate something to something else, like our expression, DAX expressions, or a formula like we saw earlier. Second is greater than sign, third is less than sign, greater than equal to, less than equal to, and please check how do we write not equal to. Not equal to is written as left angular bracket and right angular bracket to represent not equal to. Very important to know over here. Next, we move ahead with text concatenation operator, in which single and ampersand is used for concatenation. Again, a very minor trivial case of distinguish between. And second is a logical operator, wherein two things are to simultaneously expressions are evaluated, and only when both are found to be true it moves ahead. Similarly, vertical bars are for OR operator. When you are working with either or condition and you're okay with either or the OR value to take precedence, then you should go ahead with the OR operator. Basically, once you have a grip of these operators and you know how to make query expression, then half of your base is done, right? So again, parenthesis is used for two of the things, that is precedence and the grouping. Precedence is always inside out. Inside the parenthesis works first, then the outside. Arithmetic operators are basic arithmetic operators to be applied in your expression. No need for any more explanation. Comparison operators, only thing to take care over here is it is a single equal to used for comparison along with the left angular bracket and the right angular bracket for not equal to. Rest of the operators are basic as a commonsensical alphabet or the symbol which would guide you to make your own query expression. And then there comes the text concatenation operator, which is a single ampersand. And then the next is the logic operator. So let's have a look at few of these in our example and then we move ahead. So like we see in this example, let's go ahead. Yeah, in this example, we'll see where has this come from. It has come from total revenue. So if you see this parenthesis and it has this, so that means sum will only take care once this invoice revenue from invoices is calculated and bought in one place. So it is already present, that's why the sum takes over. So this is first part of it. Now if I want to calculate and I want to concatenate something as, I want to say Power BI just for your demo, I say this equal to, it does not fix this, it needs two values. Again, if you see, one part of it is text, the rest of the part is getting converted into the text because I have this thing. If I want something as, if I want to write students with space, students space Power BI. So this gets converted to student space Power BI. A good way of demonstrating an ampersand. And let's say the same placard, I just copy it, I paste it to demo something different. I move ahead. Let me correct my formula over here just to bring in this entity in place. Okay. Now both of them get refreshed. That's okay. I want to change this to something else. So I can write my measures as new measure, right? And I can say I'll show you all these options. Multiplication. In this case, I can say using parentheses, I can say 8 multiplied by 5 plus 3. So ideally, it would calculate 8 into 5 plus 3, 43. So if I want to show this to you, let's use that as your revenue, 43, like a multiplication. Let's change it to something else. So if I want to say divided by 10, it should return me 4. It returned me 4. This was a division example. Addition is done. If I say minus 43 or minus 40 in this scenario, it would calculate and give me 0. There you are. So this is how I am doing plus minus multiplication division. If I say if, right, a logical test, that means I want to do 8 into 5 equals 40, then I write true, else I write false. So in this case, it says true. So this is the logical operator. It took precedence first to calculate something, then it checked equal to sign, and then it returned a value that is getting shown over here. Again, a very useful stuff to begin with. Then I can do this or operator in a larger context of the scheme of things. However, it is not required over here. So all in all, these operators what we saw today are quite great, and let's check these comparison operator. It is a good way of doing less than equal to 40, true. If I say this, is it less than 40? It would say false. Again, less than equal to, similarly greater than equal to. Let's check not equal to. So this is another way of writing not equal to, but Power BI does not accept that. Power BI has its own way of writing not equal to. A programming background will guide you to write this, but yeah, again, this is not equal to. Then you are left with logical and or. Ampersand is clear, and logical and or would be taken ahead in our future discussions as and when the case arises. So this is all about the operators in the DAX queries. Simple, easy, break it down and move ahead. Thank you. So now moving on. The third most important thing which will be a part of a DAX expression or a DAX query or expressions if you call it so, is the functions. These are inbuilt formulas pre-saved and given to Power BI Desktop Designer to use and makes it organization specific measures. A more important way of saying this is there are half-baked items already present to use and exploit to generate your org specific formulas. So these are aiders to your work and reduces your calculation on certain areas of usage. There are about 200 functions which are readily available in data analysis expression, that is DAX formulas. These are broadly classified into date and time functions, time intelligent functions, filter functions, information functions, logical functions, parent and child functions, statistical functions, text functions, math and trigonometrical functions. So if I have to tell you, date and time functions are similar to the ones which we use in Excel as in today, etc. Time intelligent functions are the functions which would, based on today's date, would be able to calculate certain things as in what is the MTD, month till date, what is YTD, year to date, what is previous year same time, previous year same quarter, what is the first day of the month, what is the last day of the month, kind of a function. Filter functions are those functions wherein out of the broad data which you would get in the table set, you want to exclude certain data based on certain conditions. Like I said in my earlier example, what if you want to see only the content of the or the revenue of the socks as an item amongst all the items of clothing which you've bought or which you sell? In this case, you can have a filter function. Make use of these filter function to make a measure, your custom measure, which will only consider price or the sum of the ranges which are of type socks and ignore all the other items present. Information function is like if you want to check, is this true, is this false, is it first, is it last, that kind of a function can be called as an information function. Logical functions are basic, if else, if, like we saw today, if something is equal to something then make it as true, those are logical functions. Parent child functions are if the child function return something for the parent to take care and move ahead. So these are like a tree kind of a function wherein you can have a subchild or a subset evaluated first and passed on to the parent. Statistical functions and math functions are those functions which are basically available on your calculator, as in scientific calculator might ask for a sine, cosine, tan kind of a function, whereas statistical functions are one of those, and the text functions are is text, convert to text kind of the functions. Overall, this is the broad range of DAX formulas. Let's check few of them on our own. If I have to tell you, what if I want to see what is today as a measure? So let's go back to our query and I say I just rename it first to something known as functions, right? This is multiplication, so I will rename it to DAX functions, right? So this gets renamed everywhere. This gets off, right? If I select it, it gets DAX function. Now let's check if I want to showcase what is today as a function. It does not take any argument. It will show me a value. Today is this date. What if let's go back and see what do I have next. What is the year if I want to check? So, year of a particular date, and I say date of type 2019 comma 10 comma 12. It is YYMMDD, and then I do a parenthesis. First it would evaluate the inner parenthesis and then generate the outer parenthesis. So in this case it should return me a value 2019 as an year. Again, what if I want to check a date diff between two? So if I say date diff between date 1 and date 2. So if I say date and it is 2018 and I say date 2, This is first date. I have to close the parenthesis. Now the second date moves on. It gives you a good prompt in your Power BI as to consider what. So if I say again a date which is 2019 comma 01, close the date and the date parenthesis, and I say interval of how many days have passed or month have passed. Let's say in terms of month, and I say okay. What will it show it to me? As 12 months has been passed from this date to this date. What if I change something like 9 and 8, right? What happens over here? It gives me minus 12. So it is like a forward calculating date diff, wherein you would calculate from the day going forward. A very important things to do or know while working with dates. Date value. Now let's see what is date value. So you need not know everything, right? However, converts a date in the form of text to date in the date format time. 2019-0101. Let's see if it works. It doesn't work because it is not in the text format. It still doesn't work. So let's see date value. It converts a date in the form of text to the date in the interval. So let's try 201-01-2019. If that's right, it will calculate, or else it won't. Yes. So this is one of the methods. If you try with some other method, let's see what does it say. It does calculate it. Now, is it an MMDDYY or is it a DDMMYY? Good way of doing it is this, right? What if I make this as 13 and I make this as 1? Will it consider MMDDYY or DDMMYY? This is fine. And if I say so, it's intelligent to identify is it a DDMMYY or MMDDYY. A good way of doing that. Date add, my favorite function to make use of. If I say date add, I say dates and number of interval, right? I can say moves the given set of days by a specified interval. So if I say date and I say 2019 comma 10 comma 01, I close this, and I say number of intervals is 1 and my interval is day. So it would convert this 1st of October to 2nd of October and display. I have missed something over here. What is it? If you know me, then I have missed this. Okay. Let's check it again. This gets sorted over here. This gets sorted over here. So I have to sort this and I have to sort this. First, there must be specify a column. So in this case, you have to specify a column name which is of type date. In this case, let's convert something available to us. Employee birth date. Example, if I move it, it cannot display. Why? Because that visual cannot handle this value. So if I convert this to this, why does it not display? calculation measure, table of multiply value was supplied where the single value was expected. So in this case, a single value expectation let us down. Let's go ahead. Let's consider a column as first date. From which column? Let me see. Birth date, right? And I say dot date, and I say closed. First date of this, and then I see what happens. There is something different. Let's drill it down. Identify. Okay, and I say this first date. I say this, that's this. Yes. Then I say this. Then I say 1. Too many arguments are passed to the first date function. The maximum argument of this is 1. So let's do one thing. Let's break it down when you are in stuff. First date, then you say of birth date dot date. Is this working? Yes. Then let's move on to calculate date add. That is 1/1/1937. Date add to this function, comma 1, comma date. And if I go ahead and I say this, so instead of 1 1 it should be 1 2. There you go. This is what I was trying to demonstrate. Next, dates between. These are certain beautiful functions which we can learn. Dates between two dates, right? Returns dates between two dates. 19, 01, 01, and start date is again this, and end dates is month is again 1, but my day has moved ahead. I say closed. Does he need a table valued function? Column date reference is the first. So a column which has that date is brought to be in. So example, let's go ahead with, there you go. There is nobody bought or in this. But if I say 37 and 37, then it gives me certain, not yet. So dates between is not helping us over here. We'll come back to this. We need to give them birth date, comma. What is not helping you? 1, 2. If I say this and I say this, okay, We'll come back to this. Moving on. Now, when we say dates MTB, okay, when I say dates MTB, instead of that, I could have used MTD. Oh my god, it needs a column again. Let's fix this. So dates between and date add would always be a sub element in your major query. Like we see, dates between will not work on its own. Dates between will need, or dates add, like our earlier example or our statement, will need a column which has dates in it, and it will need the start date and end date for which you want to calculate something. So like I said, if you want to calculate the revenues earned in this period, right, then you would have to use the query which is calculate then sum then for these dates, so on and so forth. Then you can say end of the month is a good function which you can easily say end of the month, and it needs one argument. It can again take the similar state like we had earlier, like I say calculate the sum of revenue from invoices, right, and separate it with the other thing saying end of the month of which date. If I have to put, it will take date of again 1996 comma 01 comma 07 comma 01. So for the month of July 1996, right, I want to calculate some end of the month. Am I able to do that? It is not permitting you to do that. Why? Because it has some restrictions. If I take this off, I only want to calculate something based on this. Am I permitted to do that? It must need a column. So these functions will not be a standalone function. It would need something before it to take it further. So for these things, I want to calculate sum is fine. Unexpected parameter. Why? So if I calculate this as one part of it, and then this is my second part of it, then I can safely assume that that's done. No, it's not taking it. So on, we'll come back to this. Int. This is a good value of int. Let's take this ahead. Int. If I say integer function for a number like 123.34, so it will round it off to a value 123. If I say 5, it would round it off to 123 again. If I say 90, it will round it off to 123. So this is the lower rounding. Now this is conversion of uppercase, rounds down to nearest round up. I say round up to the nearest number, okay, and number of digits are 0, 123. If I say 56, it comes up to 4. If I say 49, it's still 144. It's because I'm rounding off to upward side. So this is all the functions what we have in Power BI for us. Rest of them can be explored using all these values. You can explore it, calculate, ceiling, count, cross filter, join, all of it, date, data table, day, and so on and so forth. So this is where the DAX functions end for us. Thank you. Let's now have a look at some of our earlier examples wherein these queries and expressions have been used in great length. Coming back to our earlier example of human resources sample, wherein the users have built another altogether different calculation, which includes all the different types of filters and the query, wherein they have used the term filter where they are filtering the employee table wherein the termination date is blank. So wherever the termination date is blank in the employee table, only those records are calculated for counting. So the ask was, how do we identify active members of right now in the database? So to identify the active values, the user, the designer, made sure that all active members do not have termination date, and therefore for all those records which do not have termination date should be summed and clubbed up to get a value of active members. So to get the active employees list, user wrote this DAX expression wherein he is calculating something and naming it as employee count, that is a measure. And the way to fill this employee count is by accessing the employee table and only taking those rows where the termination date is not blank, right? So he identified the blank rows and filtered them out from the employee table, and whatever was left is shown in this active employees output. Similarly, the same thing can be applied to active supply last year. So same period last year for the date. So for the date range, if you consider, you can get it same period last year of all the actives which we've calculated earlier. Similarly, this is interesting. Divide active YOR by variable by active supply. So if you want certain division to take place, you have one formula, one measure, and this is the other measure. So you can use the term divide to measure one over the other. This is the way. Active minus last year's value is this year's variable, year on year variation. What is an average age? You can do rounding of an average of age and round it to 0 decimal. Average tenure, so these are all average functions. How do you calculate the bad hires? You do the sum of the bad hires for the same period last year. So that's what you get. What is bad hires? Bad hires is hire date minus termination date into -1 to make it positive is greater than 61. Then it is a bad hire. That means anybody who's worked for less than 61 days is a bad hire, right? How do you do the employee count? Only those members in this given period from the max period, only those members are taken which are active and has an employee date. So if you expand this, you get this. Then you have separation, year on year variation. So first, what is separation? Separation is count of employee ID, right? But you filter whose is blank is not blank. So only those active members, right? So is blank. Filter those employees which are not in the termination date. So people who do not have or who rather has a termination date, only those value is considered ahead. Exactly opposite of the active one. When you write the not, it becomes like this. This and active has only one difference is that the not operator negates the blank termination date clause. So that means it is not blank termination date. That means you have to only consider those active values. This means it is only active values and it get assigned to a counting of this. So those many separations would have happened. Separations last year, that is same period last year, is what you can do. Year on year change, you can divide and find out. Sum of bad hires, you can do sum of bad hires, and so on and so forth. So this is the way you would ideally would have to check all the different kinds of formulas as per your organizational need, making use of certain inbuilt formulas given to you. Let's have a quick recap of what we've discussed today. We started to analyze how the DAX queries are built. We checked what components make up a DAX expression. What would the DAX query accept? What would the DAX query return? DAX query would accept all the operators and it would return either a scalar or a tabular value. In certain scenarios, like we observed, it would only take or accept a column to begin with as one of the arguments. We saw DAX query having functions. We saw functions can take 0 or more arguments. We saw how to filter it, the data, in one of the HR example, wherein the filter technique is used to exclude certain rows and only use the remaining rows for further analysis. We checked what does sum mean. We checked how does calculate come into picture. We saw how these all expressions when put into Power BI helps us make our own organization or dashboard or Power BI specific formulas. DAX expressions are the body, whereas there are definite parts to the DAX expression which are given to us by Power BI. There are functions. At the same time, these queries will help us give a better formula. So this is how DAX is a building block of Power BI dashboard. We also saw how those DAX expression map back to the dashboard. We also saw how to have the DAX expression filtered, if not via the filter attribute in the query, then by using the slicers. All in all, this is all about DAX in Power BI. Next session would be the concluding session of our study, wherein we would check some cheat sheets for Power BI in terms of development, in terms of standards, and then we'll move on to a good project. Thank you and happy learning.